We shall now start part two of the theories of circular motion, right? So in part one of this circular motion theory, we have seen the various terminologies of angular velocity, acceleration, and whenever the body turns, moves in a circular path, it has got a resultant acceleration which is pointed towards the center of the circle, and we have seen the value of that acceleration. And that acceleration obviously is associated with the force, and the force is directed towards the center. And that force is called centripetal force, and the force is applied, rather, the origin of the force is different in different cases. Sometimes it's a tension, sometimes it is gravitation, sometimes it is friction, etc. So this was in part one. In part two, we shall see a particular phenomena that happens whenever somebody is moving in a circular path. And this is a very common phenomenon. Every one of you must have experienced. That is, whenever you are, or not only you, anybody is traveling in a circular path, anybody is traveling in a circular path, then all along the path, let us say this section, I have noticed that if this is the path, and suppose you are riding a cycle or a motorbike, you have a tendency to incline towards the center of the circle. Say this is the cycle tire, and this is a cycle handle. You have a tendency to lean towards the center. And that leaning, maybe you lean by an angle theta. Why do you do that? You do that because whenever you have to travel in a circular path, the acceleration towards the center, acceleration towards the center, which we named earlier A, this is equal to, we have seen this value is equal to g square by r. The linear velocity square by r, radius of the circle. This is the radius of the circle. And this acceleration EA, always, who will produce this acceleration? There has to be some force, that is the what is called centripetal force, is called centripetal force. This is equal to mass multiplied by acceleration, mv square by r. Now, where from this force will come? When you incline, that time, there is always a force, that is always the force. Suppose this is your gravitational force, and gravitational force, there is a component of this force towards the left. Component of the force towards the left. And this force provides you the centripetal force and makes it easy for you to take a turn. But here, the problem is you have to all estimate. When you first start learning cycling, whenever you try to take turns, you fall down once or twice, and then finally you make an estimate that what is your linear speed at which you are going, what is the radius of this path, And finally, you make an estimate that how much to tilt inward so that your force inside is exactly equal to centripetal force required because centripetal force depends upon the velocity, radius, and arm and m. This is the centripetal force, and you have to create the required amount of centripetal force. If your inward force is more than the required centripetal force, then you will fall inside the circle. If it is more than the centripetal force, it is less than the centripetal force, you will fall outside the circle. So you will have many accidents. Anyway, but the road designers, they have found a solution to this problem. What they have done, this road here, if you take a section of the road here is slightly inclined. This also you must have noticed in many cases, normally in highways, inclined by an angle of theta, say. The road here is slightly inclined. And say your motorbike is here. Then this motorbike downward force is mg, and it has got a reaction perpendicular to the road surface, and say this reaction is R. The component of R vertically is R cos theta. Component of R horizontally is R sin theta. This R sin theta will provide you the inward centripetal force, right? This R sin theta we can write in this case, and this arrangement is called banking of road. Banking of the road. And R sin theta provides centripetal force. That's the centripetal force. So R sin theta has to be equal to mv square by R. Has to be equal to mv square by R. And R cos theta, vertical force, R cos theta has to be equal to vertically downward force mg. From here we find, if we divide the first one by the second one, we would find tan theta is equal to m v square by R multiplied by 1 upon mg is equal to square by gr. It does not depend upon that. So theta, the banking required, is equal to tan inverse v square by gr. This is an interesting equation. It shows if your velocity v is higher, you are going at a very fast speed, then you need more theta. That means banking should be more. And if a radius of curvature is high, that means if the circle is a very large circle, then you need theta less, you need banking less. Whereas if the radius of curvature is small, but it is a small circle, and you are trying to take a very quick turn, then you need a theta more. That means you need more banking. So this is what is called banking of the road in order to provide the centripetal force. We shall take another issue. that is part of the theory. Here, you know, just let me bring a circle here. Let me bring a circle here. Circle will be very useful to explain a part of the theory. This is a circle. Consider this is the earth. Consider this is the earth. Now, if you consider this is the earth and this is the equatorial line, and this line goes through the North Pole and South Pole. So the earth is continuously rotating like this on its axis. The point is, if the earth is rotating like this, suppose you are here, suppose you are here, then you are rotating on a circle on this circle. That means you are rotating on this circle, and let's say your mass is m. You are rotating on this circle. Definitely, there is a centripetal force applied on you, a force applied on you towards the earth. Now, this additional force alters your weight. Your weight is your mass multiplied by acceleration due to gravity. So, the G, value of G is equal to 9.8 meter per second square. The question comes, what is this G? Actually, this value is if the equator and the earth is not rotating. Since the earth is always rotating, there are extra forces on you which will alter the value of G. But this alteration is so small that for all practical purposes, we consider G is equal to 9.8 meter per second square. Now, let us see what is the actual value of G. This is the centripetal force. Let's say this is centripetal force, Cp, and accordingly, there will be a centrifugal force, Cf, centrifugal force. Now, centripetal and centrifugal forces are equal and opposite, but I have drawn it larger just for the sake of drawing, so that the drawing is not very cumbersome. And mg, original mg that we have learned so far, actually measurement of weight towards the center of the earth. This is mg. This is mg. But now I find I have a force mg on me, plus there is another centrifugal force. And this centrifugal force is equal to centripetal force. The centrifugal force we have seen in earlier class is equal to m r omega square, where omega is the angular velocity of the earth. Right? Now, let us just give some name of the drawing. Let's say this point is O. Let's say this point is P. So OP is equal to mg. And but actually the force on me is actually the resultant of this force, mg force plus centrifugal force. So in order to find out the resultant, I have to complete this rectangular parallelogram, and this is the resultant force. This resultant force in this drawing shows outside the earth, but it will not happen because CF, centrifugal force, is very, very small. It will be always inside the earth. But for the sake of clearing the drawing to you, I have drawn it in a larger, right? And so, and let us make this point is Q. So, PO is mg. Instead of writing OP, let me write is PO, considering the direction of the force. So PO is mg and PQ is the mg dash, where g dash is the resultant g. G dash is the resultant g. Resultant gravitational acceleration, right? Now, now we have to find out what is the value of g dash. That means the resulting gravitational force of attraction, right? And let us make this point PS. Then PS is the centrifugal force. PS is equal to centrifugal force, which is equal to, we know from the last day's lesson, centrifugal force equal to m omega square multiplied by r, or the radius of rotation. Radius of rotation, this r is equal to, if this radius of the earth is r, then this radius is r, and this is theta, then radius of rotation of the person is r cos theta. R cos theta. Because the person is rotating on this circle. This is r cos theta, right? Then, and the resultant force on the person is PQ. Resultant force on the body is equal to PQ. We have to only find out what is the magnitude of PQ. Then our whole problem will be solved. We know how to find out the resultant from this rectangular parallelogram. From that formula, we know that PQ square, resultant square, is equal to one vector square plus another vector square, PS square, plus 2, the product of the two vectors, 2 PO PS multiplied by cos of the angle between them. Now, what is the angle between them? If this is theta, this is 180 minus theta. Cos of 180 minus theta. By the way, possibly you know from your school level geography knowledge, this angle theta is also called the latitude of that place. Latitude of that place. For example, latitude of the center of Calcutta, India, somewhere in MP, is something around 23, 24 degrees, right? So latitude is always available from the geography. So we have PQ square and we have to find out PQ. So now we can easily find out everything. What is PO? PO is mg. So this is m square g square. What is PS? Is m omega square r cos theta. So this is, you can write m omega square r cos theta whole square plus 2 is again mg. PO is again mg. So in place of PO, we write mg. And this 2 I have forgot to write. So let us put 2 here. 2 mg multiplied by PS is m omega square r cos theta. This is PS itself has a term of theta. Then cos of 180 minus theta. Cos of 180 minus theta is equal to minus cos theta from your trigonometry class. So there will be another cos theta, and this plus sign will be erased. Instead of that plus sign, there will be minus sign, minus 2, etc., etc. Right? So, and PQ is the mg. PQ, P to Q, PO is mg, PQ is mg dash. That means apparent, where g dash is the apparent gravitational attraction. So from here we get mg dash whole square, that is PQ square, equal to m square g square plus squaring this whole thing is m square omega to the power 4 r square cos square theta minus 2. There are two m here, minus 2 m square g omega square r cos square theta. From here we get mg dash whole square is equal to, or we write m square g square, that will be better to write. M square g dash square. We write m square g dash square is equal to m square g square plus here m square omega to the power 4 r square cos square theta minus 2 m square g square r cos square theta. Now from all this is m square, m square, m square, m square, m square gets cancelled, which is evident because this value of g or g dash does not depend upon the mass of the body. It is independent of the mass of the body. So therefore, here we get g dash square is equal to g square plus omega to the power 4 plus omega to the power 4 r square cos square theta minus 2g omega square r square theta. Now the point is, this value of omega, that means angular velocity of rotation of the earth, omega is of the order of 10 to the power minus 4 radian per second. As a result, what do we do? That omega to the power 4 is much, much, much less than omega square. And omega to the power 4 is ignored. Omega to the power 4 term is ignored. If we ignore the omega to the power 4 term, then what do we find? G dash square equal to G square minus, this term is ignored, minus 2G omega square r cos square theta. In that case, from here we find G is equal to under root of this thing. That means G square minus 2G square r cos square theta whole to the power half. Now, you possibly have already done the binomial theorem in your mathematics class, where you have seen a plus b whole to the power n is equal to a to the power n plus nc1 a to the power n minus 1 b plus, and there are other terms. Last term is b to the power n. This is the binomial theorem. Now, in this case, when the term omega is there, the first, it is enough to take first two terms. The third term onward will be so small that it can be easily ignored. So we can write here only two terms enough, I should say. So this is G. From here we find G equal to, first it is a to the power n, first term is G square, so G square to the power half, G square to the power half minus NC1, value of NC1 is always n, and n is here half, so it is half, and that multiplied by a to the power n minus 1. My a is G square, so it is G square to the power n is half, that minus 1. Multiplied by b is 2G omega square r cos square theta plus other terms which you can ignore. This is equal to G square to the power half is only G minus, here this 2 and this 2 gets cancelled. And what is G square to the power half minus 1? Let me do it somewhere here. G square to the power half minus 1 is equal to G square to the power minus half. Is equal to, minus half is actually 1 upon root 2. The 1 upon root of G square. This is equal to 1 by G. So, so g square to the power half minus 1 is actually 1 by g. So minus 1 by g. That multiplied by, we have another g lying here, g omega square r square theta. So this g gets cancelled. So what do you find? This g dash, or the apparent force of gravitation, acceleration of gravitation, is equal to actual acceleration of gravitation g minus omega square r cos square theta. So this is how. So apparent weight of the body, or rather resultant weight of the body, will be given by g dash. But the point is, when we measure our body weight, if I am 60 kg, I am always saying 60 kg. I do not consider the rotation of the earth, because the value of omega is so small, this doesn't make any practical difference. And also, you will find on equator, where theta is equal to 0, there g dash is equal to g minus 1 square r. Because, so this will be the resultant acceleration due to gravitation on the equator, and the more you go towards the pole, its value is given by this. So this should complete your theory part, essential theory part, rather say, essential part of your theory of the chapter of circular motion.